Ooh, we have binary operations and logarithms in the same problem. So even before we start, we know we are going to have to be creative in manipulating the expressions using the properties of logarithms. So what is the question? We're defining binary operations diamond and heart by a diamond b is a to the power of log base 7 of b, while a heart b is a to the same power, except we're taking the reciprocal this time. And this is defined for all real numbers a and b for which these expressions are defined. The sequence a sub n is defined recursively, starting with a sub 3 is 3 heart 2, and as a practice, let's quickly write that down. A sub 3 is going to be a is 3, b is 2, so that's going to be 3 over 1 over log base 7 of 2. Not the most pretty expression, but who knows, maybe we can manipulate that. And a sub n is n heart n minus 1 diamond a sub n minus 1 for all integers n greater than or equal to 4. To the nearest integer, what is log base 7 of a sub? Of course, 2019. How do we start? Well, if you're anyone like me, I don't want to work with diamonds and hearts. I want to work with logarithms because logarithms is what I'm used to. So let's start by rewriting this expression in terms of logarithms and see if we can simplify the expression or derive any meaningful property from the resulting expression. So we know a sub n is n heart n minus 1, and just by looking at this, we know that's n over 1 over log base 7 of b, which is n minus 1. And with that expression, we're doing diamond a sub n minus 1. Now in this case, this thing is a, and this a sub n minus 1 is b. So just plugging that right into this gets us n to the power of 1 over log base 7 of n minus 1 times log base 7 of b, which is log base 7 of a sub n minus 1. And as some of you may be yelling out, we can simplify this exponent. What is this exponent? Well, that may remind you of a change of base formula. In fact, this entire exponent is log base n minus 1 of a sub n minus 1. Why? Well, we're essentially applying change of base formula with the new base of 7. You know this entire thing is equal to log base 7 of a sub n minus 1 over log base 7 of n minus 1 from algebra 2, and that's precisely what we have. So we're writing a more compact expression when we combine them. But now what do? We have a sub n being n to this crazy power, and in my opinion, it's much easier to work with this thing compared to this entire thing. So can we isolate the exponent somehow? And the answer is yes. Just take log base n of both sides. Then, because a sub n is equal to this, we know log base n of a sub n is going to be the exponent, or log base n minus 1 of a sub n minus 1, and we know this thing is going to hold for all integers n greater than or equal to 4. But now, wait a bit. What is this telling us about log base n of a sub n? If you do not see it, think about it for a moment. Now I will tell you. Well, think about plugging n equals to 4 into the expression. Then we're going to get log base 4 of a sub 4 is equal to log base 3 of a sub 3. Well, this also works when n is equal to 5. Well, in that case, we're going to get log base 5 of a sub 5 is equal to log base 4 of a sub 4, and these are the same. And I bet you see it now. When n is equal to 6, we can do it again. Log base 6 of a sub 6 is log base 5 of a sub 5. So we have this chain of equality, which is telling us that log base n of a sub n always stays the same. And this type of expression in a problem is called invariant. So we have log base n of a sub n being our invariant. And in a problem like this, usually when we find an invariant, we are 90% of the way there, and that's actually the case. Using this invariant, we care about a sub 2019. So using this, we can try to find log base 2019 of a sub 2019, which we know always stays the same. So we can set it equal to log base 3 of a sub 3, which we know how to find because we know a sub 3. In particular, just by looking at this, we know log base 3 of a sub 3 is equal to 1 over log base 7 of 2 because you get the exponent when you take the log. So we are almost done. We want to find the log base 7 of a sub 2019. We know log base 2019 of a sub 2019 is 1 over log base 7 of 2. So we want to change the base to 7. So let's apply change of base formula once again. So we know this thing becomes log base 7 of a sub 2019. This is what we want to find. Divided by log base 7 of 2019 is 1 over log base 7 of 2. And isolating this, we get that our price, log base 7 of a sub 2019, is log base 7 of 2019 over log base 7 of 2. And we can apply the reverse change of base formula once again. This is the third time, getting us log base 2 of 2019. So that's the answer we are looking for. But we want to find the nearest integer to what we got. So log base 2 of 2019, well, 2 to the 10th power is 1024, which means 2 to the 11th is 2048, and we want to find the log base 2 of 2019. So just by looking at this, we know we are closer to 11 than 10, so we are going to get approximately 11 as our final answer. So we know the answer to this question is D.